Unique New York. Unique New York.
Hey, Jesse, have you ever seen Anchorman?
Anchorman? You mean this movie? Why, yes, I have. I even own it.
Well, have you seen that scene where Jack Black kicks Baxter off the bridge?
I have. Have you?
Yes. Have you ever wondered how much force that took?
Funny you asked me that question. I haven't had this detailed description of how it even happened.
Well, I would love to know.
Okay, well, let me tell you, world. All right, so the question is, how much force does it take to kick Baxter off the bridge? And indeed, was it possible for Jack Black to kick Baxter off the bridge? Now, I wondered this question since the first time I saw the movie, and it's a good thing my physics class made me look up this certain situation. So here we go. So the question is, how much force is it going to take for Jack Black to kick Baxter off the bridge? And is it possible? So I said to myself, is it possible, Jesse? And I answered to myself, I think it is. So there's my hypothesis on whether I think it is possible or not. So I went out to this website that I'm accrediting right here, Livestrong.com, and they had an example of a soccer player kicking the ball and how much force it took for him to do that. So I compared Jack Black to this much more athletic man kicking a soccer ball. So the equation we have to find the force is the force to kick Baxter off the bridge equals mass of Baxter times the velocity of the kick divided by how much time Jack Black's foot came in contact with Baxter. So I looked up the average mass of what a male Border Terrier weighs, which is what Baxter is, if you did not know. And the average male Border Terrier weighs 7 kilograms. So that's the weight we're going to use for Baxter. We went back to Livestrong.com to find some more averages to base our estimations off of. And they said that the kicker was kicking at about 30 meters per second. I said to myself, can Jack Black kick as quick as a professional soccer player again? No, he cannot. So I estimated that he would kick the ball at 15 meters per second instead of the 30 meters per second of the soccer player. So we kept going. And the soccer player on Livestrong.com came in contact with the ball for, I believe, 45 seconds. And then I said to myself again, is Jack Black really that quick? And the answer was, no, he's not. So I estimated that his foot came in contact with the ball for 0.3 seconds. So we're going to start by figuring out the equation. If you remember, the top half of the equation for force is mass times the velocity. So we figured out Baxter's mass would be 7 kilograms, and his velocity would be 15 meters per second. The equation equals 105 kilograms meters per second. So we put that back into the original equation that we had, which is mass times the velocity over time. So we found out that this equals, as we said, 105 kilograms meters per second. And as I said, Jack Black is not as quick as the soccer player kicking at 0.05 seconds. So his time is 0.3 seconds. So if we do the calculations here, we find that the force to kick Baxter off the bridge by the unathletic Jack Black would take 350 newtons. So you ask yourself, Jesse, is 350 newtons a reasonable amount of newtons to kick a dog off a bridge? So we reverted back to Livestrong.com. And on Livestrong.com, it told us that the soccer player kicked with an average of 400 newtons. So our 350 newtons of kicking Baxter off the bridge indeed does make sense. Now, some of you may ask me, Jesse, why didn't you figure out a problem with Superman? Or maybe with Thor? Because that would be much more interesting. But I said, why don't I do something that nobody else would think to do? And who doesn't love Will Ferrell? And who doesn't love Jack Black? So, thank you, world, for listening. Next time, on Jesse's Physics Problems, we're going to figure out whether Will Ferrell can really get out of the glass case of emotion. Thank you.